Hello, I'm Corey. Today we're going to get started in the significant changes to the 2015 International Codes, primarily focusing on mechanical code, but we'll incorporate in a little bit from the fuel gas code and from the plumbing code as well. So if you're going to look at mechanical code, it's a little bit different than other code books, right? Because other code books, for instance, the National Electric Code or the Uniform Plumbing Code, if you look at those code books, they're pretty much all inclusive. And what I mean by that is if you were to find a reference in there sending you to another reference or text or document of some sort, that is not going to be enforceable by a code official in those other books. It's there to give supporting documentation to that code and to make your job a little bit easier by helping you to understand what they're talking about. However, it's not actually enforceable. Much like the handbooks. When you go through the handbooks for the electrical code, you've got all kinds of great text and documents and drawings that are showing you interpretations of what the code is designed to meet or trying to accomplish in a certain section. However, that document is not enforceable. Only the actual electrical code itself is going to be enforceable. However, with the mechanical code, it is more of a reference document. You're going to find all kinds of references to other books, standards, codes, whatnot, and you're going to have to follow those if those are acceptable in the municipality that you're doing work in. Okay, so there's all kinds of examples we're going to run into over the course of the next little bit of time we share together. But if you look here, we've got all kinds of examples. Right? We've got mechanical code. That's right. It references to itself. We've got the International Fuel Gas Code, the International Energy Conservation Code, the International Residential Code, Building Code, Fire Code, and some of the ASHRAE fundamentals. But you also have BOCA and SMACNA and NFPA 70 and all of these other supporting documents. Okay, remember, when the mechanical code references you someplace, it means something. Mechanical code gives you a good fundamental baseline knowledge on the topic at hand, but then references you to other documents to complete that knowledge based on the scenario. Let me give you an example. Okay, so one of the hot topics for the last decade has been flexible gas line, CSST. Well, if you go to Chapter 3 in the International Mechanical Code, it's going to tell you that there's basically been an across-the-table handshake when it comes to fuel gas code, okay, and running fuel gas piping or natural gas pipe. Okay, that's been done with the AGA, basically saying the documents that they support, like the International Fuel Gas Code, the National Fuel Gas Code, things like that, where they are the expert. The mechanical code is not going to come in there and traipse on that. They're not going to change or alter what they're talking about. Okay, and so what they're going to do is they're going to tell you that anytime that you're installing fuel gas line, okay, say a normal residential dwelling unit, you're going to install natural gas piping. Okay, so anything that you install is going to be done according to the fuel gas code. Okay, that's one of the references that you've got in the mechanical code in Chapter 3. Okay, so it references everything over to the fuel gas code, but there's an exception. And one of the unique things in the mechanical code, other than the references, are the exceptions. The exceptions are also enforceable. The exception to some will be a much bigger portion of the code than the code itself. The exception is any dwelling unit 3 stories or less under rooftop with an egress window and any accessory structures, those are going to be referenced over to the International Residential Code. Now, what does that mean? That means those references are going to send you different places based on the type of design of the home, or the dwelling unit or business or commercial property that you're working on. But those references are only valid if the city or state in which you're working in actually follow those. So there's a lot to take into consideration when we're talking about code. So as we go through here, take it for a grain of salt. Okay, it's not solely to go through here and just read code and to give you my opinion, and then that's the end of it. That's far from my goal here. My goal is to give you an idea to think about. We're going to go through, we're going to talk about code. I'm going to give you some potential applications on a lot of it, and you're going to take away from that situations that you may not have thought of before, but now you're going to. Why? Because if you don't, you could run out and do a job, run into one of these issues, and it could cost you some serious change. So let's go ahead and get started. So the first thing, very, very small section of this class, and in fact, this is the only real section of this class that'll have anything to do with International Plumbing Code. Now, why do I even reference that at all? Because, well, in many of the states we live in, as a mechanical contractor, you're able to put in water heaters, okay, and pull a permit on the mechanical side. Okay, so the irony is, in a lot of those areas, you have one inspector that's going to inspect for the mechanical side and for the plumbing side. And oftentimes he's going to pick whichever one's going to be the most strict, and he's going to follow that on both sides of the equation. Okay, and 504.6 talks about something that's really, really rudimentary, something that we normally don't even think about when we're putting in a water heater. So you ever go out and put in a water heater and you take off the discharge tube, right? The pipe that's connected to the pop-off. A lot of times we just unscrew it from the old water heater, and then we install the new water heater and put it onto the new water heater when we're done, right? The intention is that it never gets used anyway. It's just to direct the water towards the floor. At least that's most people's view. Code says that's not necessarily the case, right? It is trying to direct it down to the floor, but there are parameters we got to follow, right? The distance from the floor that the termination of that pop-off tube's got to be is between 2 inches and 6 inches above the floor. It keeps the splash down, right? The splatter. If somebody were to be in that proximity at any given time that pop-off valve was to go ahead and cut loose, it would splash everywhere, right? And we wouldn't want somebody to get burned. So bringing that down closer to the floor helps add safety to that job. Now, what about if a water heater is up on a platform, which oftentimes happens if you're in a floodplain or your basement normally takes on water when it rains, or potentially just a commercial establishment which oftentimes you're going to have a shelf with several water heaters on it. What then? Well, the pop-off tube is supposed to go down to the floor where the floor drain is. So even though you've got the water heater base is clear up here and you got a platform it's sitting on, you're going to have to run that pop-off tube possibly even further down to where the actual floor is, between 2 and 6 inches off of that floor space where the drain is. Now 504.7.2, I'm not going to spend a lot of time on it. It's kind of goofy. There's a section in code that says if you've got a water heater and it's in an application where it requires a drain pan, but the water heater you're replacing doesn't actually have a drain pan. There wasn't a requirement in the past or whatnot, and maybe there wasn't even anyone there to enforce code, and there wasn't even code that had to be followed at the time that this thing was installed. But now you're going back with a water heater and you do have to follow code, and code says in this application, whatever it may be, maybe it's in a closet with no floor drain, maybe it's above a finished space, you know, those couple of applications would require you to have some kind of a pan underneath it. So if there is a leak of the water heater, it's not just going to go out into the structure and damage the structure. There's going to be some fail safes involved with that pan. So if the water heater you're replacing doesn't have a pan already, then code does not require you to put a pan in on the new one. It's part of the existing building side of things. And that's 504.7.2. Now, let me tell you, I don't know personally any inspectors that will enforce it that way, right? Inspectors are there for basically two things. They want to make sure that the people are safe and that the structure is safe. And that's primarily a big focus of their job. So if you've got a water heater that's put in an application where even if it gets a small leak, it's going to be able to go over into the wall, into the ceiling, whatnot, and damage or weaken the structure, that's going to make the structure unsafe, which is by fault going to make the people unsafe. So they're not going to allow that in most instances. Okay, but the reason I point it out is because code sometimes requires a little bit closer understanding, a little bit better, broad view of what they're looking at here. Okay, so keep that in mind as we're going forward. Getting back into the mechanical code side of things. 306.1 talks about access. Now, if you'll remember for previous sections of code, access really dealt with working space, right? And working space on the actual appliance itself. And of course, in these applications, we're counting water heaters and furnaces as appliances. If you've looked at those definitions in the code book, appliances are things that we normally call equipment, and equipment is everything else. So talking about appliances here, normally the working space that we're talking about is 30 inches wide, 30 inches deep and level. And that's on an air conditioning condenser outside, that's on a furnace down in the basement, a water heater, whatnot. Okay, 306.1 has extended that to mechanical controls that control the appliance, not just the appliance themselves. Now, there are some things to think about here. There are some residential applications that could be difficult with that, because now we have controls that used to just be humidistats, but now all of the operational low voltage wire goes through the humidistat on some of the fancier ones and actually controls the operation of the furnace. So that could be considered in this category. We've got zoning controls that are oftentimes in really horrible areas to work on. They work great, but they're installed either on a plenum or return air or on the backside or maybe on a wall. Very difficult areas to work on. This is telling you, hey, that might not work going forward. So it's something for you to think about because it's in code. Now, for you commercial guys, I think this is one of those things that really could affect the commercial side of things, because, pneumatic controls, hydronic controls, those things are never in an easy spot to work on or diagnose or replace for that matter. So if that's the case, would you have to incorporate that into your service procedures? Well, traditionally, if there's something already there and you're out there for a service related issue and you're just replacing that part that's already there, you're not going to have to comply with those changes to code. However, there are some places around the country that have changed that portion of their viewpoint on following code, and they put a dollar limit on it to a customer. So if you're over a certain dollar limit, that's considered now a major repair in those locations. And because it's a major repair, you would have to do any code updates that are required in order to make that installation comply with current code. So that's something to think about. 307.2.5 talks about drain maintenance. And I'll tell you, you're probably going to be just like me. I never thought that I'd be around long enough to see us complicate the HVAC drains like we have and like we are. Okay, so 307.2.5 talks about drain maintenance, and our drain maintenance in the past has always been, well, we pour some bleach down the drain, or we'll use one of those tools with the CO2 and we'll blow through it. Some people have used a sludge sucker. That used to be one of my favorite tools, where you're actually able to draw from outside using nitrogen. Great tool. Okay, but now code says you got to have a planned maintenance procedure. And the planned maintenance procedure has to be something that's put in place for maintenance, not just, oh, by the way, it's there because that's the way the manufacturer wants you to drain it out. And what do I mean by that? Well, if you've got a condensate drain that goes across the top of the furnace, has a T in there because that's the way the manufacturer wants it, so you don't build up back pressure and splash over the pan inside of the equipment. But that T is sitting right there, and then of course it drains down maybe into the condensate pump, or maybe over to a floor drain or something like that. Okay, that T being there because it's part of the actual drain does not count as part of the planned maintenance procedure, and so you may still be required to put a 3/4 inch flush out in there so that you can get in there and actually clean that drain. Now, it's a small thing. It doesn't add a lot of expense to the job, but it's one more thing. So it's something there for you to think about. You know, this goes right along with one of the common sense applications that was put into code in the last couple of cycles that hasn't always been something that we've done. You know, a couple of cycles ago, they put in, you know, verbiage that said, okay, your condensate drains can never be smaller than 3/4 inch diameter on the mechanical side of things. If your condensate drain coming out of the pan is larger than that, so your connection at the pan larger than that, then you have to drain out that bigger size the entire way. So you can't minimize the size of that drain. If it's smaller than 3/4, you've got to increase it to 3/4 and finish draining it out, unless doing so changes the functionality of the equipment. So, and then in addition to that, you're required to put in a secondary or overflow drain if the pan permits that, if there's actually a connection for that. So just within the last couple of code cycles, we've added some complexity to just putting in a normal condensate drain. So when you think about it, previously we've added requirements for size. Okay, it doesn't mean that you can't use some of the traditional methods. Vinyl tube, I get a lot of guys that ask me about vinyl tube. Can I use vinyl tube for my drain? It doesn't say anything about you're not able to use vinyl tube. People just have gone to the PVC on the 3/4 side because vinyl tube, once you get over that 5/8 vinyl, which used to be incredibly popular for, you know, most of the early 2000s, that stuff is easy to kind of maneuver and guide around stuff, and it's small enough that if you run it under a carpet in a basement, you know, it doesn't create much of a tripping hazard. But when you get up into 3/4, 3/4 likes to maintain its kind of curled up status. So even when you're running across the floor, it does weird bowing things, and it gets all crustied up a little bit quicker, and it's not nearly as cheap as a 5/8. So a lot of people use the 3/4 PVC because it's easier to run and they feel that it looks a little bit nicer. In my opinion, you know, use what you guys use. Just make sure that you're complying with code. So 3/4 internal diameter is code, and you have to have the secondary drain hooked up. Most pans come with 2 drains, right? You got a primary and a secondary. You have to have it hooked up. Some places allow you just to have a short little overflow, right? The wet switch that comes out in a stub, so that if you get water into that secondary drain hole, it cuts off the appliance. Okay, whatever the case, got to have the secondary drain hooked up. And then also, our current code is changing that to make you have a planned maintenance procedure for cleaning that drain. It does not say that you can't cut the pipe no more. That's not the intention of code, to limit the things you can do. You can still cut the pipe. That's obviously last case scenario as far as code goes. That's not a plan. That's things have gone sideways, and now we need to do some major repair here. So you can still do that, but you've got to make other provisions for regular routine maintenance. 307.3 talks about condensate pumps, and this is really, really common sense. So if you've got a condensate pump, and let me remove my picture here so you can see that whole section of code. If you've got a condensate pump, and that condensate pump is the only means of drain, or the primary means of drain, then obviously if it overflows, you've got a problem, because there's no drain around there to take the water away that's running onto the floor. And the whole idea of the condensate pump is to keep water off of the floor. So if a condensate pump is your primary source of condensate, is taking that water over to a drain someplace, then you have to have the overflow hooked up, right? And that just basically ties everything back into the equipment. So if it starts to overflow, the float switch comes up, it'll cut off the appliance from running. And that's the main thing. You've got to have that hooked into the low voltage so that before it overflows, it shuts everything down. 403.321. Outdoor air for dwelling units. Again, another thing that it really is surprising to see how quickly that the industry is advancing on air changes per hour and basically air change per human occupancy. Even in a regular residential dwelling unit, which this is what we're talking about, right? Outdoor air for dwelling units. An outdoor air ventilation system shall be installed for each dwelling unit. Now look at this section of code. Does it say only in new construction? No, it doesn't. But that's how we think about it, right? In our mind, we're thinking, oh, this is just new construction stuff. It doesn't make any mention of new construction. That's the scary part. This is where I want you to start thinking, right? Because code is telling you that this is a requirement for each dwelling unit. And there are some places that have instilled this in retro work as well. And that makes it really, really difficult, right? Because when it comes to bringing in outdoor air for human occupancy, where does that air come from? Well, we got, you look on mechanical code. Mechanical code says ducts connected to the return plenum and connected to an outdoor termination are allowed according to the mechanical code, right? So we've got a collar on the return side and a little slinky that goes from the return side to the outdoor wall, and we've got a termination point on there. So when the fan's running, it's drawing air through the return air, which by default is going to draw air through that fresh air exchange. That's been done for decades. Hey, there are some inherent problems in that, and many municipalities no longer accept that. Now, why? Now think to yourself, why would they not accept something that's been used for so long? Well, when we used to recommend that and actually do that primarily on new construction, we did that for homes not recommending that they run their fan all the time, right? It's a genius idea if you're only running the fan with heat and cool. That way it's only bringing in air during the heating and cooling process. So the air that's being brought in is going right through the system and it's being heated, cooled, dehumidified. Now we're recommending people run their fan 24/7 oftentimes, and there's some equipment out there that the fan goes down to just a fraction of its normal operating speed and it never shuts off in the off cycle, ever. If that's the case, now we'd be drawing in air all the time, even during the off cycle, so it would just be dumping unconditioned air into the space that would then eventually have to be heated, cooled, dehumidified, humidified, all those things. Not to mention you're bringing in contaminants from outside. So it's not as good a deal now as what it used to be. So now you've got energy code to think about. You've got residential code to think about. You've got all kinds of other things other than just what mechanical code is telling you here, right? That's why it's important to know all facets of code. If you're thinking about this, you've got to remember there's also a requirement for combustion air, which we'll talk about here in just a little bit. That requirement for combustion air says if you've got a single pipe system or you have a natural draft system that draws air from the space that it sits in to burn, like a natural draft water heater, power vented water heater, single pipe 90% furnace, gravity feed boiler, any of those things that burn the air from the room that it sits in, you have to bring combustion air in from outside. So you've got a special system to bring air in from the outside so that it can support the burning process with that appliance. That's it, one system. Okay, and there are sections of code that tell you that has to be a mechanical system and it has to be controlled so that the air that comes in to be burned can be controlled on, off, and whatnot. Not just an open hole to the outside. Well, now we're also saying that you have to bring in air for people. And energy code says those have to be two separate processes. You can't use the combustion air coming in as a default for your air changes per hour for occupancy. You want to add a little bit more difficulty to that? How far can you be from an exhaust on an appliance to an intake that comes into the home for human occupancy? Well, how about for combustion air? Right? Combustion air usually isn't an issue unless you look at other codes other than just the International Mechanical Code. There are some codes out there that tell you if you've got two appliances, the exhaust from one appliance can't be any closer than 10 feet from the intake of the other appliance, which would be your combustion air draw. Not to mention, you can't be within 10 feet with your fresh air intake from any exhaust. So think about that. You've got this little corner room where you've got a furnace and a water heater set up, and potentially you could have to go out one side with the water heater because it's power vent, the other side with the furnace because it's PVC vent 90%, and then you have to bring in potentially combustion air for that as well. And then in addition to that, bring in air for human occupancy. Well, some guys will say, well, why would you go through all that for the combustion air? You know, bring in your second pipe. Bring in your intake pipe running all the way to the furnace. That doesn't help the water heater. The water heater's power vent, it burns the air from the space, so you're still going to have to bring in combustion air to suffice that. And there's also a lot of inspectors that will allow you to put a return grill in the bottom of the door and the top of the door for the mechanical room. But what if there's not enough air coming into the rest of the house to draw from those other spaces to support the mechanical room? Right? I'm not saying that this is the only way to think about this, but I am saying this is a way to think about it, and it might be worst case scenario, but you know as well as I do that if it's in code, eventually it could affect you in the way that you do your business. And so you do have to put some thought into these harder to plan for ordeals. Okay, so let's look at this calculation, right? We're getting a little bit divergent here on what we're talking about. 403.321 outdoor air for dwelling units. What's that calculation? Okay, your airflow rate in CFMs is going to be equal to 0.03 times the square foot of the floor space that you're serving plus the constant of 7.5 times the number of bedrooms plus one more bedroom. That's your calculation. It's not a tough calculation at all to make, but it's there. It's another process. And if by chance you've got the scenario that we just talked about and you've got water heater, furnace, air for occupancy, those are small furnace rooms that we're dealing with a lot of times residentially or in multifamily dwellings. So that air for occupancy might come from a space that's outside of the mechanical room, which would require you to run it through finished ceiling and out the side of a finished space. That's pretty tough. Think about it. 50482, bit of a victory. I don't know very many inspectors that are going to look at things like this. I don't know many sales guys or owners that are going to look at things like this, but it's there. 50482, dryer exhaust duct installation. Dryer duct shall be supported every 4 foot. That's pretty straightforward. And you may use screws. Oh my goodness. That's your change right there. You might be able to use screws on this stuff. Oh wait, there's more to the code. Long as they don't go through the skin of the metal more than 1/8 of an inch into the duct. Well, that's pretty tough, right? And I've talked to inspectors and I've said, are you going to allow that? They said, no way am I going to allow that. I said, well, why? This sounds like this might be a little easier for the guys, a little bit better support. And they said, yeah, I understand that. But they're telling me I can't go through 1/8 of an inch. And the reason you can't go through 1/8 of an inch is because of spindling, right? You got a piece of screw sticking into the metal, and then the dryer lint and stuff starts to spindle around that screw, and all of a sudden now you've got a big ball of dryer lint in there that's potentially a fire hazard, and also that's causing an obstruction to the airflow. So, you know, those kinds of things make a difference. If he was going to allow that, inspector speaking to me, he said, think about that. The screws you're going to use are probably zip screws, using a 1/4-inch chuck and a drill. What's the difference from the outside, from looking at the head of that, the part that goes in the chuck, on a 2-inch long screw and some weird fictional screw that might only go through 1/8 of an inch? What's the difference in the way they look? There isn't any. So the only way that he could be sure that the size of the screw, or the piercing point of that screw, is 1/8 of an inch is watching you put them in, or have you take them all back out and check them. It's just too much work for this particular inspector, which he had a great point. You know, he said, why would I do that? Why would I waste that much time in doing that? You know, it's just adding a lot of work to the job. Okay, in the same breath, it says something about tape, right? It talks about tape is to be used as a sealant, not as a supporting means. The residential code supports this as well, right? So what does that actually mean, right? Here we're going back to what is the use of tape? What's the proper terminology for tape? And this is just really kind of feels painful to me, and most likely to you too. Well, what are we talking about here? Okay, and I've looked into this a little bit, and the examples that I got are, you know, things that I've done in the past, and you probably have too. If you're using tape around a joint of duct so that it doesn't pull apart, right, or sag over time, that's support. That's not sealing. If you're using it on 90s, putting a piece of tape around the 90 joint so it doesn't swivel, so it stays in place, that's also support. If you're using it on a flue pipe so that the flue pipe is sealed, is your tape listed for sealing flue gas, or even for the temperature that the flue is going to be operating at? Right? Those are things to think about. Real life scenarios there. 6015 talks about return air openings. And this just adds credibility to stuff that we've been doing for years, right? You got a furnace, it's down maybe in a crawl space or in a basement area, and we don't have enough return air upstairs. We're doing a retro job. I know that I need more than the 1 30-inch register in the hallway, so how do I get more return air so this thing burns right? Well, some people will just cut a return air grill right into the side of the duct downstairs or into the side of the furnace. Okay, is that okay? Well, they give us some examples. There's several more than what I have listed here, but these were ones that I found really interesting and pertinent to what we're talking about. They shall not be located less than 10 foot in any direction from a draft hood or an open combusting chamber. Okay, that's pretty straightforward. Usually we got a furnace. Right next to the furnace is going to be the return air on one side. And so either on that side of the return air or on the other side of the furnace, oftentimes a water heater. So the idea is we don't want to have return air sucking out of that space, creating a negative draw for that water heater so that it doesn't vent properly. It shall be equal to or less than the supply in that space. Well, most of us are accustomed to seeing returns and supplies in nearly every room, except not a kitchen oftentimes, and hopefully not a bathroom on the returns. Okay, so you've got to have supply into the space that's at least equal to the return that's being taken out of there. Now, why? So we can churn that air. We're supplying heated, cooled, dehumidified air to that room. We're drawing out the stale air that's been in there, mixing with everything else. And so we're keeping that churning, which is healthier for people, and then it also will create less hot and cold pockets. The return from one dwelling cannot discharge into another dwelling. That's an interesting one. You have to think about that for a second. Why would somebody do that? Well, I'll tell you why people have done that in the past. Think about it. you have a duplex out there. A lot of times those duplexes are just really, really big homes. They weren't always created to be a duplex. Somebody somewhere along the line decided, you know what, this is way too big for one family. I'm going to put a wall down the middle. We're going to separate it. We're going to make it a two-family home, make it a duplex. And even though they separate almost everything in the home, there are often two things that are never separated. One of those things is oftentimes going to be the sewer. Obviously, your septic, your sewer, those types of things never usually separated. And the second thing is oftentimes your HVAC system. You'll have the whole house split in two except for a communal basement where the washer and dryer is, the furnace is, all of that kind of stuff. And even though you might say to yourself, yeah, you know what, you're getting crazy now because we would zone that anyway. Of course you would zone that. No, if you zone it and it's a 100-degree day out or it's a 0-degree day out, there's a good chance both sides are going to call for heating or cooling at the same time. And if that's the case, you're going to be drawing return air from one space, mixing it together, and supplying it out into both spaces. Right? So there's no way to avoid drawing air from one space and putting it into another space in that type of scenario. So that would be a great example of where this portion of code would come into play. Next portion, shall not be taken from a furnace or boiler room or kitchen or bathroom. Okay, now that's something you got to think about too. Us HVACR guys, refrigeration guys, electricians, we all throw around the terminology of mechanical room often. Okay, but mechanical room really is only a commercial application. It's an other than dwelling unit application. That's the term, an other than dwelling unit application for a mechanical room. There are some parameters. And in a lot of instances, mechanical room has been changed, right? It went from mechanical room to occupied mechanical room and mechanical room, and then it was machine room, and there's 5 different designations there, and it goes on and on and on. Okay, mechanical room is not in your home. Okay? However, a furnace room or a boiler room could be. It depends on how your inspector views that. So if you've got a furnace room down in the basement, you're not allowed to draw return air from that space. Okay? If you've got your furnace down in the basement and there's no walls, the inspector could effectively deem that entire basement space a furnace room. Then you're not allowed to draw return air from there at all. Now, that seems a little far-fetched, but let me give you a more practical example. A few code cycles ago, the definition of bathroom changed from a room to a space that has a basin, one other fixture. What's a basin? A sink, basically. Okay, so you have a sink and a toilet, or a sink and a shower. And, you know, the idea was not to make things complicated. The idea was to accommodate the more modern style bathroom areas, right? You go into a hotel, you've got the shower and the toilet in one room, and you've got the vanity and the mirrors and all that kind of stuff in another room. So 2 people can be getting ready at one time. And that was the intent of the code, to accommodate that and make sure that things were wired, plumbed, and mechanically speaking, installed the way that they should be. Right? That makes sense, hopefully, to you. But there were interpretations of that code that I never would have foresaw. Somebody goes down in a basement, and in the Midwest, there's all kinds of basements that have a sink and a shower just randomly in the basement, right? It's nothing fancy, and there's no walls around it. That's just the way it was, an unfinished basement. It's where, you know, things, when you're dirty on the farm, you come in, you go downstairs, you don't go to the nice bathroom to get all washed up, you go downstairs. When us kids would come in from playing at the park or whatever, you know, that might be where the shower was, whatever. But with no delineation walls, we had inspectors come in and say, well, with no delineation walls, I'm considering this entire basement a bathroom. That's a tough interpretation. And if that interpretation's made, think about that, how that affects everything else. You can't draw combustion air from a bathroom. So that means that power vented water heater and a single pipe 90% furnace or any 80% furnace or boiler may not comply with that application without doing major structural changes to that downstairs area. Electrical wiring may not comply. Okay, so those things make a difference. How the inspector looks at it makes all the difference in the world. So let me give you a piece of advice before we go any further. If you're in doubt, simply ask. Ask your inspector, how do you view this? What's your take on this? And there's a reason that I tell you that. A lot of places in life, it's easier to ask for forgiveness, right? You just do it, and then later on you say, you know what? I shouldn't have done that. I'm sorry. That's expensive in the HVACR game because the inspector is going to have the same view before you do it as he does after you do it. The only difference is you spent money not asking. So even though he would have told you no if you'd have asked in the first place, you didn't ask. He's still going to tell you no. You're still going to have to change it and fit what the code interpretation is. So my recommendation is to ask in advance. That's oftentimes going to be your best case scenario. All right, 8029 talks about door swing clearance, which is, this should go without saying, but it oftentimes doesn't. Okay, vent terminals shall be located so that the door cannot swing within 12 inches of the vent. And you can't use guards or door stops to achieve this. So what are we talking about here? Okay, this is one of the weirdest arguments I've heard in one of our classes. Okay, so if you are going strictly off of code and where you can terminate your vents, you can be within 12 inches of a door or a window as long as you've got your intake and exhaust both run, direct vent style, right? Many places around the United States do not comply with that. They make it be much farther away, so there's no chance of recirculating into that space and filling that structure, okay? But that's besides the point. Okay, so code allows you to be there. What this is telling you, if you've got an openable door and you've got a vent that's coming out in that proximity, you're not allowed to have it within 12 inches of the complete swing of that door. And if you've got a door stop there or a railing or something that keeps it from opening up to hit that flue that's over here or that vent, that doesn't count. You got to use your imagination. What would happen if it swang all the way open? Would it hit that? And then you got to be 12 inches beyond that radius. Okay, so the argument was, well, yeah, but that's not right because code allows me to be within 12 inches. Yeah, it does. It doesn't say it shall be within 12 inches, right? So think about that. If you've got a door right here and you got your vents coming out right here, and it's too close because now the door can hit your vents, this is telling you in code you're too close. But even though code allows you to be within 12 inches of the door, as long as it doesn't hit it, it is hitting it. It doesn't say you have to be there. Manufacturer says you could put it here where you can open and close the door and it's still going to work just fine, right? They're not telling you you shall be that close to the door. They're saying you can be. Moving those vents over is clearly the best case scenario because then you're not going to damage them with the door, even if code didn't tell you to do so. It would make a lot of common sense to not put that someplace where a door could hit it. And there's all kinds of different places in all the codes that say that you're not supposed to run stuff through or obstruct an openable door or window, so it's just common sense. And could be bad mojo to do so anyway. 11023 talks about refrigerant access ports, and this has been a long drawn out process. Okay, when you're talking about refrigerant access ports, what this section of code says, in addition to 1101.10, which deals with this as well, you must add a locking access port anytime refrigerant is added or recovered from refrigeration or air conditioning systems. Now, what's the definition of added or recovered? If you're putting hoses on there, guess what? There's a change of refrigerant. Many inspectors tell you that if you're putting your hoses on there, your gauges on there, there's an exchange of refrigerant, and when you're done, it's got to be up to current code. Now, refrigerant access ports, having the locking access caps on there, has been a really long process because it's changed so much. Right? If you would have looked at this in 2009 said any refrigerant containing vessel has to have a locking access port cap. Keep people from huffing the refrigerant, right? And that was actually cited in there as a reason why in the code and commentary, so the thicker code book that gives explanation of the code. Now, that went as far as the refrigerant container in my van, the one on top of Long John Silver's, the one in the side of your house didn't make any difference. Okay, then in 2012 they came back and said, well, that's not exactly the case. Only if it's accessible to the general public, then you have to put the locking access port caps on there. Okay, so if it's on the side of my house, just between our houses, and there's no fence to keep people out from there, well, then I'd have to put a locking access port cap on there. And this was a direct example that was given as well. If there was a privacy fence there, and I'd have to work as a person from the general public to get to that condensing unit, then I'd have to put I wouldn't have to put locking access port caps on there because there is a means to keep you out of there. Okay, if it's on a rooftop, I wouldn't have to put it on there. But if it's sitting down in the alleyway where the drive-through is, I probably will have to. So now they said not everywhere. Currently, in the 2015 code, they're saying not only if it's accessible to the general public do they want you to put locking access port caps on there, but you don't have to do it proactively. Meaning you don't have to call your whole customer base and say, hey, we've serviced you 3 years ago. I want to make sure that somebody come out and put locking access port caps on there. That's not the case. Right now you can do it as you're doing your service calls. So you go out there, you check the refrigerant levels or your superheater subcooling, or you make a repair that requires you put your gauges on. When you leave, you put the locking access port caps on there. So there's a couple sections here that deal with the International Fuel Gas Code. 304.1 talks about general air for combustion, and this has also changed. Okay, this is a pretty good size change. And this section here tells you that if you've got a category 1 appliance, a natural draft appliance, this is going to, this calculation that we've dealt with in the past is going to deal with you solely. Calculation for combustion air to be brought in according to 304.5 are meant to extend only to category 1. Well, what were those calculations? Well, if you've got a category 1 appliance or natural draft appliance, you've got to bring in 50 cubic feet per 1,000 BTUs of input per hour for all the appliances served. Okay, so if you've got a 60,000 BTU furnace, a 40,000 BTU water heater, they're both natural draft, then you would have to bring in 5,000 cubic feet of air per hour while those things are running. Okay, so that was originally extended to everything, category 1, category 4. Now they're coming back and saying, yeah, that's not going to work for category 4 or condensing gas appliances, 90% plus type appliances. That has to be drawn in according to whatever the manufacturer says it is. Okay, so if you single pipe a furnace and it's a 90% furnace, you have to figure out from the manufacturer how much air has to come back into the structure to support drawing the air in from the space it sits, burning it, and exhausting it out. That air has to be replaced, like for like. Okay? Only the manufacturer can tell you how much has to be brought back in. 310.1.1 dealing with CSST. CSST gas piping systems containing one or more segments of CSST shall be bonded to the electrical service grounding electrode system. Right? Doesn't say that it has to go back to any particular point on the grounding electrode system, but there are municipalities that say this is the only way you're going to do it, and that's okay. Code is broad, but the purpose of municipality inspectors are to narrow that down into, hey, this is what we're going to do, and there are reasons why. And then go out and enforce that. And that's okay, as long as we have a uniform way that we're doing it in those areas. 310.1.1.1 Bonding jumper length. Bonding jumper isn't to be longer than 75 feet. You may need additional ground rods to aid in longer applications. Think about that. Why? Well, when you think about it, if you've got to go to the grounding electrode system, they say the bonding jumper is not to be longer than 75 feet. So there are some that have made the attempt to skirt that portion of the code because there's such a long distance between where they need to be bonding and where they need to terminate at, that they will put their clamp on, run 75 feet of bond wire, run a ground rod, clamp to that, clamp a second 75-foot length of bonding wire, and go all the way to wherever their termination on the grounding electrode system is going to be. And there are guys that immediately jump on that and say, no, you cannot do that because now that ground is an isolated ground. No, it's not. It still is going down to the grounding electrode system. So it still is going back and connecting to the grounded system. So it isn't isolated at all, but it doesn't, you know, where there's a will, there's a way, right? There's a reason that they only want a 75-foot bonding wire. Because when you got, you know, static buildup on CSST, or you've got an inadvertent lightning strike, which isn't a direct lightning strike, that means it happened over there and it came up through the ground and wants to get into your system. That bonding wire, if that thing is longer than 75 feet, there's a good chance that it may not make it to where it's going. Right? The grounding and the bonding don't like long distances. So the shorter the distance, the more practical application that you'll be dealing with there. So just a little side note. This is an example of what the fuel gas code actually gives you. If you look at the International Fuel Gas Code, or you look at, better yet, the updates to the international codes and go to the fuel gas code section, this is an exact picture of what they give you in there, right? They allow you to hook to the rigid metal pipe or to the fitting on the CSST. So rigid metal pipe in this particular instance would be like black iron from the service, between the service and the CSST, or you can hook onto the nut of the CSST. Keep in mind, if you're going to have a bonding clamp go onto the nut of the CSST, it has to be listed for the product, so you'll have to have a actual manufacturer-made bonding clamp for that CSST. Gas tight track pipe examples, which they make those. But what I'm saying as a point is you can't just use anything that you've got on the shelf. It has to be listed for those products if you put it on that nut. If you put it on the black iron, then it just has to be listed for the black iron, which are, you know, much more prevalent. One of the things that also changed is for header pipes. When it comes to header pipes, they used to want you to run a bonding clamp on each of those fittings of the CSST for the header pipe and go from the black iron to each of those fittings and then over the grounding electrode system. And now they're saying one bonding electrode, one clamping point, and have it go over to the grounding electrode system. And that's it. Okay, 6-gauge copper or stranded, also listed in code. Okay, however, that 6-gauge isn't a given. So it's not just always 6-gauge. You have to size the stuff. So the longer the length, you may have to actually increase the size of that wire. And there are some municipalities that don't allow you to use, 6-gauge. It's 4-gauge only. And there's some that don't allow you to use stranded. They want solid only. So code is your guideline, but make sure that you understand what your inspector is asking out of you. That's much more valuable. 4022 talks about gas pipe sizing. There used to be all kinds of tables and equations that you could use to tell you how big the gas pipe has to be coming into the structure. It's easy now. You have to do the same thing on a natural gas structure inside the city as what we've been doing on LP systems out in the country for decades. You add up all of the input BTUs from all of the appliances that are in that structure that are going to be served by that that gas meter, and you act like they're all going to run at the same time. And that's the size of gas pipe you got to bring into the home. Now, where do you run into problems on this? Sometimes you run into problems on the high efficient water heaters, the tankless water heaters. Many of those, so even their smallest sizes are around 100,000 BTUs. And even though you might not use all 100,000 BTUs, you have to size your gas piping for that, okay, as a possibility. Oftentimes they're requiring 1-inch line to come in dedicated just for that. 3/4 is fairly common as well. So what happens if you've got that, and that's all you've got available for the house, or maybe, you know, more than half of it, but you haven't served your furnace yet, you haven't served your stove, maybe you got a fireplace in there. Those things have to be taken into consideration as well. So make sure that you're doing your sizing properly, and if you don't have enough, fix it. 4045, fittings in concealed locations. This is another real tough one for some folks, right? Code allows, and there's actually pictures given in the international code updates. They allow you to conceal threaded T's, elbows, couplings, as well as any welds or listed fittings that are allowed to be concealed for black iron, right? They've changed that, right? They're not going to get rid of CSST or flexible gas line or anything like that. It's not what code's there for. The stuff is listed for the application that we're using it in, and there are methods by which we're supposed to install it. But what they're doing is they're opening up the ability to use black iron in the absence of using flexible gas line. You think about it. 30 years ago, when we were at our grandparents' house for Christmas and all the kids were downstairs playing, what did you see in that basement? Nothing. It was unfinished, right? So getting from the gas meter to the furnace and then over to the floor just below the stove was easy. We didn't need to conceal any fittings, so everything was running black iron. We didn't have flexible gas line other than range connectors and such. So why do we have it now? Well, because now you go down in Grandma's basement, it's finished. Everything has to be concealed. And there was no allowances or tolerances for concealing those black iron fittings in the past. They had to be accessible. Now, they didn't have to be open, but they had to be accessible. Now, the only thing that has to be accessible are serviceable fittings, shutoffs, unions, flares, things like that. They also have the higher leak potentials. 50341, plastic pipe for venting. You got to use what the manufacturer says, and that goes with 503693 as well. When you're trying to figure out what you can use for venting applications now, code has changed. They used to allow you to use anything that was listed for the application, even if it was made by third party. Now, anything you're using for vent, doesn't matter if it's category 4 or category 2, okay? Anything other than category 1, which is natural draft, has to have the venting applications listed by the manufacturer. So the type of vent pipe you can use, the length of the run, and the size of the pipe. Those all have got to be listed by the manufacturer, okay? Regardless of what the actual product listing itself is. The manufactured product that you're actually installing has to be listed for the application. Thanks a lot for joining me today with the mechanical code updates for 2015. Hopefully we've related a little bit of the plumbing code, a lot of the mechanical code, and a little bit of the fuel gas code all back into one big ball so that we can see you can't just know one code and have that be good, because even though your state or municipality may not follow all of the codes we talked about just now, they're going to have some variation of those types of codes, or maybe local municipal code. And this is just an exercise to show you that you have to be able to be flexible enough and sharp enough to look at a code, see its reference to another one, and see how they go together and how they may affect your job going forward. Thanks a lot. Have a nice day.